So what I'm going to talk to you about is really taking it a step further and saying, okay, we have all these problems. What can we do to make sure that our agricultural system becomes a little more whole than it is now? And I should add a preface of a personal story. I am an agronomist by training, so I deal with crops, plants, soils, and things like that. When I got into picking agriculture as my choice, I had this dream as a young person of agriculture being such a wonderful thing, and man in balance with the environment, and such a poetic and really kind of literary almost experience about agriculture. Maybe Virgil was in my back of having studied in Italy for a long time. I don't know. But obviously hard reality sets in, and you realize that agriculture is probably one of the most polluting things on Earth. And I keep saying, and I have it somewhere, that it's probably, and Kathy, you may contradict me, but it's probably the largest and oldest geoengineering process that mankind has done to alter the environment. So I won't delve more into the challenges of agriculture, but basically how do we provide food, feed, fiber, energy, growing world population, climate change, oil pressures, urbanization, and all that. I should add to what Joshua was saying is that here in the U.S., we are really talking about big eutrophication problems. This is a NOAA picture of the hypoxia in the Gulf of Mexico that mostly comes from the farm fields in our part of the world. I should also add that this is a very hard, grainy thing to see, but that red thing there is the impact of greenhouse gas, CO2 equivalent of agriculture. 80% of that, more or less, it really comes from nitrous oxide, which is really coming from the degradation of nitrogen fertilizers. So what do we do about it? And do we have the right crops or not? Through the centuries, we went from true horsepower to mechanical horsepower, but the issues are the same. How do we feed people, get the energy we need, and all the other uses we want to do? How does a resilient landscape look like? What can we do with that? And so I will take you a little closer to home in the agricultural Midwest. But the basic idea of what we do is really that this is a system-level issue. We cannot take food production on one side, energy production, bioenergy production on the other side, the fiber on the other side, and the conservation on the other one. Every practice, every use of resources really has to be seen with a lens in which we really take care of both agricultural production, the conservation, the bioenergy development in particular case, and rural economics and development. All of this with a perhaps more balanced impact where we take the ecology, the culture, the politics, and the economics all together. We don't have that little reddish part here on the ecology. Everything has to be more in balance. So that's what we are trying to do. And again, we are really going in a small scale. And this wasn't supposed to be like this, but it got jammed up. And really means to say that landscapes in agriculture are very dynamic and they change with time. So the slide before, the picture before this, the transition, was a picture of a tall grass prairie, which was what we had in Illinois back in the time. But, and this is the last century, 1922, Staley opened its first soybean mill in Decatur, Illinois, where they were crushing soybeans, and they were actually making marketable products, oils and other things that were not really food yet, but they were important. And sure enough, you find a market, and the landscape has changed dramatically here, and you see the increase in soybeans and how that has changed. Another big change was an organic fertilizer that enabled the shift to grain-only cropping. So you didn't have to have legumes. You didn't have to have anything that could be rotational. You have your corn, soybean, typical thing, which is what you see right here. That's a typical landscape land use right now in central Illinois, where the yellow is soybeans, the green is corn, and the next year is soybean corn, so it doesn't change. What we really want to get to is a more complex landscape like this, which has a lot of problems and costs money because it takes away some land from production, but you have filter strips, you have grassy waterways, you have riparian forests, you have wetlands, you have windbreaks, you have a lot of more dynamic features in the landscape that actually make it more, if you want to use a trite word, sustainable or more environmentally complete. I should argue that multifunctional landscapes that we're trying to get are really old. And this is an example from my hometown. This is actually a wet meadow, a marchita in Italian, which is a very ancient cultivation system, were important from France in the 12th century by the Benedictine monks. What they were doing is that it basically, in this particular case, taking the dirty water from the city of Milan, and they were actually feeding them to these winged crops so that they had a constant layer of running water in that. And what you had is two things. They would recycle all the nutrients in there, all the nitrogen, the phosphate that the people, lost, through the sewage. At the same time, we're actually reusing the thermal energy of the water, which was above zero. And with the constant flow, they were actually, as you can see, snow didn't grow, it didn't stay there. It was melting, and that allowed crops to grow very late in the winter and very early in the spring. So actually, Napoleonic troops had fresh forage for their horses, and that's why they liked that area. They really could feed them throughout. I should add that we had a very, very distinguished engineer who developed all the hydraulics for the system. It's Leonardo in 1494 developing the water stairs and the way to feed the water gently to these systems. So we can go there and take inspiration from these systems and do something. And what we have been thinking here in our own country here and try to address our issue is really how can we intensify land use in a way that we can really live for a long time with it for many, many, many times. And so the recipe for this that we have come up with is land that's not so suitable for grain production, but it's still agricultural land in production. And the concept of industrial ecology, recycling things that agriculture has been kind of reluctant to do, at least in the industrial forms. And then the main ingredient is these different crops. They're perennial crops. It's the switchgrass. It's the woody crops. It's the prairie grasses. All these grasses which are perennial, contrary to corn and soybeans. And what they can do is they develop and invest in a root system that's deep enough to actually influence deeper than the thin surface, and they can actually add as traps and do a lot of things. And what you see here is one of our field sites. This is in Nebraska, but the idea was, can we take the nitrogen that's lost by corn and recycle it into the next crops right there? And so we can actually improve on what is still impossibly low efficiency. NUE stands for nitrogen use efficiency. Corn is a very leaky system. You give 100 units of fertilizer, of nitrogen fertilizer, it only takes 60. The rest is lost through water, through air, where you want, but it's lost. If we couple it with something else, in this particular case it's bioenergy crops, because DOE funds me to look at bioenergy, but it could be forage, it could be anything else, you actually can recycle that rest of nitrogen that is actually lost. And that's what we are really trying to do. As a result, you have lower externalities, you have better crops for the farmers and a potential income. So that's what we are working on. And when we look at marginal land and all that, that's another very loaded term. What we're looking at is not really conservation land, is not land is not explored. It's really where we are already growing plants and corn in this particular case. And I'm probably the only person that thinks that a trip from Chicago to Urbana-Champaign is actually a very interesting landscape to see. Everybody sees just corn. I end up seeing places where there's erosion, places where you have risk of floods, places where nothing really grows because it's too wet. And those are the areas we're focusing on, where really farmers don't really get a whole lot. And I'll give you a good example with our field site. This is very small. Again, I'm taking you to a small scale. This is a 16-acre field, so about 6 hectares or something like that. And it's in Fairbury, Illinois. What we have here, what you see here is a product of precision ag. So farmers harvest their corn, and they have a GPS locator in there that actually records the mass, the weight of grains every, I want to say, 10 square meters or so. And so you have this very composite map, a lot of data in there, but it really gives you a really good picture of what happens at the field scale in a cornfield. You have areas where you turn into profits. There are areas where you make a lot of money as a farmer, areas that you don't make money at all, right? And that's the area we want to think about something else. Coincidentally, the same area that you have very low revenues and profits is also an area where you actually find most of the nitrogen that farmers apply is lost. It goes down about 1.5 meters way away from the root of corn. So it won't be, it's lost. It's lost to the environment. So how can a farmer spends a lot of money to put that fertilizer in? It's lost. And the corn, and they never make the money back. So what to do about it? Well, you put a barrier there, a willow barrier in this particular case, which what we did in the field, and suddenly you actually get a dramatic reduction in the loss of nitrates that go in there, and you actually sequester the nitrogen in the vegetation. I don't want to go too much into these data, but it works. It can work. The only problem is that you have a slightly longer season, and therefore you have a slightly higher water consumption. So all is good, and I think the system that we've proved is working. What if we expanded this and we looked at all this kind of land in a small watershed? This is working at watershed. We work with farmers, so we do a lot of feedback with the farmers going in the Indian Creek watershed in Livingston County, Illinois, about an hour and a half from here. And what if we changed from this to this? And the red parts in there are all the land that fits that kind of characteristics as we have in our field site. Well, we would see that we would lose some of the corn production and soybean production, at the same time would increase dramatically the production of, in this particular case, switchgrass. So what to do with that? Obviously, could we think of a way where we actually convert some of the corn that's making ethanol into lignocellulosic switchgrass that can make some better fuel from it? Can we think about forage switchgrass can replace some of the corn that goes for feed? About 40% of the corn that's grown goes for feeding animals. So can we think of that? But if we did that, then we would actually have much decreased sediment and nitrogen outputs in there, so we would improve our water. And incidentally, the same landscape that would be optimized for water quality would also provide us benefits in terms of pollinator nesting indices. So we would actually improve the livelihood of natural pollinators. So economically, this would actually be a good solution for farmers as well. If you think willows is not really a money-making endeavor, but if you substituted willow for the corn that we already seen doesn't grow very well, the opportunity cost is pretty good, unless the corn is growing really well. In that case, it's similar. But basically, there is a window there of opportunity, and I should ask, why would actually a farmer ever grow that corn in that particular part of their field? And the answer is subsidies and crop insurance, basically. So is there a better way to do it? They actually have a benefit in doing that, because what we have found is the cost of our silly willows is really much better probably than some other conservation practices in there. So there could be an incentive. The big problem in there that we don't have a market for willows yet. And we need to develop these markets and really find a way to do it. But I think that all in all, it's been proving that a system like this could actually be a lot more balanced and a lot more productive than what we have now. So in summary, really, we have multiple needs to be addressed. They all need to be addressed at the same time. And by doing that, we really need to pull it up and really have a broader view, a higher observation point where we can really think of systems approach as engineers and scientists, and really think of the system and how we optimize that. And we need to develop markets, and we need the valuation of ecosystem service. And until we put a number value on the value of making clean water, right, what society would pay for it, then we won't have a system that works. But I think we're at the point that the trading mechanisms are starting to begin even for nutrients in there. So as scientists, what do we want to do, and where can we go with this? Particularly, we need to be able to nest spatial scales, computational systems, and computer models that allow us to go from a small field to the farm, to the watershed, to the region, somehow the reverse from what Joshua is talking about, and somewhere meet us, somewhere in the middle. Temporal scales, we go from the annual crops to perennials to the scale of carbon accruals in soils. Precision agriculture, sensing networks for data-driven research will improve our models greatly. We have a tremendous amount of data that are generated, and finally, we probably have the ways to handle that data to get some meaningful information. And finally, we really need to be totally multidisciplinary in this. We need to integrate supply chains, markets, logistics, policy, economics, land ownership, the physical and the human landscape. And so that's it, and it's done because it's the thank you slide. All the people who have been working in the field with us and our sponsors.
I'd like to know what you think about GMOs.
Sorry?
Genetically engineered corn and beans. How it plays into the nutrients. Are they engineering this to use less nutrients, or how does that work out?
So genetic engineering, crops are part of the landscape already. Particularly soybeans and corn are really heavily, there's many varieties that are genetically engineered. If you talk to Monsanto, they think that it's obviously the most important thing that you can do to feed the world. There's a lot of work that's happening on trying to develop corn types, corn genotypes that are more resistant to drought, for instance, and things like that. I don't know if we have studied entirely the impacts of this, but it's not for me to say. So I don't really have a particular, other than watching what's going on, I don't really have a particular opinion whether pro or con.